guys, I'm Kumar K, your favorite teacher for DSA plus OA plus CP. Previously, I worked at Amazon and Mia.net as a software engineer despite being from a Tier 4 college. So now on this YouTube channel, we are taking a new initiative, and that initiative is that all of you already love a lot of my in-depth DSA video explanations of the hard level DSA problems and the OA problems and some CB problems as well. Now we are going to upload regular video solutions of code forces contest and Leetcode contest on this channel. It will be a team effort by me and the other team members. Now I want just three things from you people. The first thing is that whenever you solve a particular contest question which is there in the video of that particular code forces contest or lead code contest, I want you guys to put your code in the comments so other people can get help from your solution idea and logic. It can be unique and nice, right? Because I know there are many intelligent people in my YouTube community, because it is a hard level DSA OACP community filled with lots of intelligent people. And the second thing which I want from you people is like, share, subscribe. And the third thing is that whenever you face any kind of doubt or problem, you can always mention that in the comments. So hopefully you like our initiative. Ram Ram. Okay, hello guys. With the name of God, Ram Ram. We have to do the third question, which was asked in Leetcode Weekly Contest 466. So I got world rank 581 in this contest. If you are watching this video, you need to be an intermediate level in DSA. You need to be an intermediate level DSA coder. If you are not an intermediate level coder, then understand the basics of programming and please complete the best warm-up course for DSA plus OA plus CP in the country. This link must be in the description or in the document. Complete this course till the end. Once you have completed it till the end, then you can now watch the video. While explaining this, I will assume that you have done this course, okay? Now this bowl Subarrays problem, the nice thing is that there are at least 50 to 80 exactly same OA and CP level questions in our hashing prefix suffix course, specifically where the next greater element and the previous greater element concepts are discussed. So before we go ahead, it's very important that I explain you the black box of this problem. Obviously, we always start everything with the name of God. Ram Ram. So guys, you need to know that the black box means there is a concept which you might not know how it works, why it works. You just need to know that it works somehow. Only then you can understand this problem. So it is the PGE concept, right, in your book. PGE, previous greater element. Basically, if at index I write there is a 5, this is a 4, this is a 3, this is a 2, this is a 1, and this is a 8. Like this, the array is there, okay? So PGE of I should tell you the index of the number which is coming before I, but it is greater than 5. If I open the Google chat, can you tell me what will be PGE of I? What will be PGE of I? Like if you go in the backward direction, which is the first number greater than 5 which you can find? Previous greater element. Can you guys tell me which is the first greater element if you go in the backward direction of 5? It's 8. What is its index? What is its index? In terms of I, its index is I minus 1, I minus 2, I minus 3, I minus 4, I minus 5. What is its index? I minus 5. I minus 5. So that's it guys. PGE of I is I minus 5. Now guys, we have to assume that we have pre-calculated this PGE array. Basically, you know the value of PGE of 1 also, you know the previous greater element for the second element also, you know the index of the previous greater element of the third index guy also. You know the PGE till index n. We are considering one based indexing. PGE of I is I minus 5. So we assume that we have pre-calculated this array efficiently in O of n time complexity. In total, because we use monotonic stack, it can take O of 2 into n total operations. Obviously, for that concept, it has been taught in our stack course. I will try to link the documents and all those things. But for now, you need to assume that in this world there exists a PGE concept, which you can pre-calculate. Because you have pre-calculated, now PGE of I, you can know this value in O of one time because you have pre-calculated it. So for any index I, you can find the previous greater element in O of one time. That's it, guys. That's it. So you understood these things. Wow, nice, awesome, love you. Ram Ram. So, like the PGE concept, there is the NGE concept also. Next greater element. You can assume that we have pre-calculated the next greater element array also. Next greater element array means next greater element NGE of I will be NGE of I means ith element is 5. So if you go in the right hand direction, which is the first element greater than 5? It's 8, man. It's 8. Wow. So NGE of I is 8. And what is the index of 8? I plus 1, I plus 2, I plus 3, I plus 4. It is I plus 4. So NGE of I is I plus 4. Just relax and chill in your life. So these things we have calculated. So we assume that the prerequisite concept is understood as I explained in the video. The PGE plus NGE has been pre-calculated. Okay, so these things are pre-calculated. So, now let's discuss about the question itself. So question is saying that you have to count the number of good subarrays. A subarray is good if its length is greater than or equal to 3 and the minimum of okay. Like the understanding is also pretty simple. Subarray is good if length of subarray like I to j is greater than or equal to 3. The length of the subarray should be greater than or equal to 3. And the next thing, which is again very, very important, is that minimum of the end points should be greater than the maximum of the middle. Okay. I'll try to convert it to minimum of ij should be maximum of this thing. Now, obviously, when I saw it, see, there are two forms of Kumar cube. One form is normal form. Other form is, peak concentrated form. I was not in my peak concentrated form. So when I saw this, I knew I have the potential to do it. But I knew that I'm going to struggle a lot because, I'm not in constant touch with DSU. So if I try to explain you the meaning, the brute force solution is like obviously clear to you, right? A subarray is valid. Like in this session, I'm not going to explain you what is a subarray. This is for intermediate level coders. So the people who do not know subarray, they can go and do my beginner level course. So this subarray from I to j is valid, right? When it is valid? When the minimum of the ith element and jth element is still greater than the max of the middle elements. Now, is this a valid subarray, guys? If yes, react with emojis. Is the subarray I to j valid? We have to count the total number of valid subarrays. Is it a valid? Is it legit? Yes, it is legit. This will be such a nice, cute addition to our already the most brilliant hashing prefix suffix course in the country. So, yes, it is legit. So because it is legit, why it is legit? Because the minimum of the endpoints, what is the minimum of the endpoint of this subarray? Minimum of 2 comma 5 is still greater than maximum of all the middle elements. What are the middle elements? 1 1 1 1 1. So what is the max of 1 comma 1 comma 1 comma 1? It is going to be 1 only. And what is the minimum of 2 comma 5? It is 2. 2 is greater than 1. Wow, correct. This is a legit subarray. Obviously, in O of n square time, I hope you understand how to iterate all the subarrays. You can iterate all the subarrays, right? You can maintain the I comma j pointer, and for each like this is the I pointer, the j pointer. You can just check the condition, na? Is the minimum of this greater than maximum of this middle part? And the maximum of middle part also you can track. Why? Like when your I is fixed and your j is going ahead, always keep the track of max of these elements. When j goes here, this number will be included in this max. And this number mean you will know. So O of n square solution is pretty easy. But guys, one more thing you should know, that in this case I have used repeated numbers. Okay. In the actual questions, all the numbers are distinct. So everyone react with emojis if there is no doubt about the question and the brute force solution. Everyone understands how to write the O of n square code, right? In your sleep also you can write it. Now comes the analysis part, okay? Analysis. Now how do we optimize it? Directly solving it is a recipe of disaster. So just think, when can the minimum of this become greater than the maximum of all the middle elements? So see, in my brain, obviously I did lots of hit and trial, then this came to my brain. Main of the element at index I and j is greater than max of all the middle elements from I plus 1 till j minus 1. Now this can only happen, this means what, this means that this guy is strictly greater than all the elements here given here. This guy is strictly greater than all the elements given in the middle. And this guy is also strictly greater than all the elements given in the middle. If this guy is strictly greater than all the elements given in the middle, and this guy is also strictly greater than all the elements given in the middle, only then their minimum can be greater than all the elements in the middle. Everyone react with emojis if everyone can feel this. Only if the ith element is greater than all the elements in the middle and the jth element is greater than all the elements in the middle, only then the minimum of I comma j can be greater than all the elements in the middle. This is common sense. React with love emojis if you understand this. Okay. So you have understood this. This means what? This means they are trying to say that I count such valid subarray such that ith element will be the first largest element of the subarray, jth element will be the second largest element of the subarray, or vice versa. So got it? Like if you try to do analysis, count valid subarrays of two types. Which two types? Obviously all the elements are distinct, so it makes the things little easier. It should be like that only, or else it can create, I think, lots of problems. Yeah, it should be, distinct only. Later on I will deeply analyze on it though. Anyways, for now, if I get time, okay, time for one-to-one mentoring and all that work, but I love it. Now, subarray, the new definition is that the subarray from L to R is valid. Subarray from L to R is valid if A of L is the second largest element and A of R is the largest element. And the other way L to R is valid if A of L is the largest element, like these are type 1 subarrays, okay? Like these are type 2 subarrays, okay? Okay. AR is the largest element and L2R, if AL is the largest element, then A of R is the second largest element, okay? So guys, let's count type 1. So guys, do you understand? When can this condition be satisfied? If ith element is the largest element of the subarray, J is the second largest, तभी तो उनका मिनिमम बीच वाले एलिमेंट से बड़ा होगा ना, कॉमन सेंस इतना तो होगा ही. Or else J can be the largest element, and I can be the second largest one. So now I want to know in the Google chat, are you guys understanding this thing, that there are only two cases possible. The subarray can be valid only if the ith element is the largest element and the jth element is second largest element of that subarray, or reverse. I want yes from everyone. Okay. Okay. So you understand? Yeah. Yeah. Now, you guys understand these things, right? Now, listen to me very, very carefully. Okay. Very, very carefully. Listen. So, now, let's try to calculate all the valid subarrays ending at index R. Okay. Let's try to calculate all the valid subarrays ending at index R. So I think this should be easy. This is not very difficult for you people, as far as I know. Okay. Anything can happen in this life, but that's it. So if this is your index R, okay, and this has to be the largest element of the subarray, okay, this has to be the largest element of the subarray, okay. So let's try to imagine some scenario. 10, 8, okay, 10, 8, and then 9. Okay, let me write something like 10, 7, 8, then 9, then 11, then 12. Okay. So guys, you want to know all the valid subarrays ending at index R. Is this valid? Then is this valid? Then is this valid? Then is this valid? This trick I have taught gazillion times in the hashing prefix suffix course. That always consider I to J or L to R and analyze what's happening. Try to count all the subarrays ending at index R. Is this valid? Is this valid? Is this valid? Now guys, you want to calculate the valid subarrays from L to R, where R is the largest element and L is the second largest element. So guys, if you try to go to the previous greater element of R, PGE of R, 10, right? What is PGE of R? PGE of R is, right in the Google chat. What is PGE of R? 11, right? Okay, great, awesome. Let's say you find PGE of R and let's call it as index R5. This is index R5. Can you guys tell me, can R5 to R be a type 1 valid subarray? Yes or no? I am at R, I found my PGE, the previous greater element there. Can R5 to R be a type 1 valid array where R is the largest element of that subarray? Is R the largest element of this subarray anymore? Tell me, is R5 to R a valid subarray? Yes or no in the Google chat? No. So guys, that means the valid subarrays, if L2R is a valid subarray, L can only be from range R5 plus 1 to R minus 1. ये वाला नंबर आप कभी ले ही नहीं सकते. क्यों? क्योंकि आपने 10 से बड़ा नंबर ले लिया ना, तो अब 10 लार्जेस्ट कैसे रहेगा? दिमाग लगाइए ना. अब तो 11 लार्जेस्ट हो गया. हमको तो ये बंदा लार्जेस्ट चाहिए था. Whichever subarray we select, 10 should be the largest element of that subarray. That means that which arrays can become valid? Only these green color subarrays has some chance to become valid. This green color guy, this green color subarray, this green color subarray, and this green color subarray. As soon as you hit R5, you need to stop. Why? Because as soon as R5 comes, a number bigger than 10 comes. Now, if you consider any subarray from R5 or bigger than R5, 10 will not be the largest element because a larger element than 10 has come. So you need to stop. This single observation solves the whole problem. Okay. So what is the observation? Well, the observation is that, let's say R5 is nothing but what? PGE of R. Okay. So L2R is valid if L is in the range, R5 plus 1 to R minus 1. That's it. Nothing else you can do, man. The problem is actually now solved. When you are at index R, what will you do? You will say, God, please tell me which is the previous greater of R. God will say R5. Now you know that your valid L, the valid subarrays ending at index R will have their L, but L will always be in the range R plus 5, R5 plus 1, basically this to this. Now you have to check which of them are valid. That's it. That's it. That's it. Okay. Now how will you know which of them is valid? See, one thing to consider is that common sense is enough to solve the problem now. Let's say this is R, and you have now made a blocker. You now know that R5 is the previous greater element. So you are only looking at this subarray. Now guys, you know what is one very nice thing in this subarray? That the subarrays, you are only considering the subarrays from L to R, where L is in the range R5 plus 1 till R minus 1. So this is giving you leverage. What leverage it is giving you? It is giving you the leverage that it is guaranteed that in all of these subarrays, 10 is only the largest element. 11, 9, 8, 7, 10, right? 11, 9, 8, 7, 10, right? This was R. This was R5. You came to know that L can only be from R5 plus 1 index to R minus 1. So you are only considering this subarray, R5 plus 1, and this is your R. Now you consider this subarray and all the subarrays smaller than this ending at 10. All of them will have 10 only as the largest element. So your first worry has disappeared. You wanted to count type 1 subarrays na, such that AR is the largest element. ये हो गया. अब बस एक चीज चेक करनी रह गई है. Is A of L the second largest or not? That's it, baby. That's it. So what will you do? Obviously this is R. You will check what is happening here. You can see yes. If I compare 10 and 7, this is the second largest element. So you might in a hurry say that this is valid, but this subarray length is only 2. They want the valid subarrays of length 3. So even though it looks good, you don't count it in the answer, okay? Then you go and check the next number. 8, 7, 10. You know that this is the largest guy. And you know that now all the numbers you travel in this range will be less than 10 only, okay? Now you come to know 8. You see, yes, 8 is the second largest.
In 8, 7, 10, 10 is the largest, 8 is the second largest. This is a valid subarray. You count it. You just enjoy. You just count it. Wow. Now, baby, listen up. Now you see this number. You see 9, 8, 7, 10. You know 10 is the largest guy. That is fixed. But 9 is the second largest guy. You become even more happier. You count this also as the valid subarray. This much logic should be clear to you. Or else we cannot go ahead. So everyone tell me your thoughts. Yes, I'm clear if you understand that first you find this blocker R5. It means that you only need to check from R5 plus 1 till R. And here you are doing brute force, no problem. But this blocker should be clear. Why are we taking this blocker? This blocker makes sure that whatever we are checking, it is guaranteed that 10 is only the largest number there. Now we only need to check for the second largest. Okay, good. But I only got 3 yes from the people who know the solution. But what about others? Okay, good. Always I will recommend you to watch this recording again and again until it gets fully clear in your head. Okay. So now comes the deadly optimization. Not deadly. Let's call it something else. Let's call it lovely optimization. So guys, listen. Yeah, I know it's 12 a.m. but you have to study with me. Just imagine how much brain and how much effort I must be needing to get it done in such a short time in the contest. Thanks to God. Thanks to God. Now, listen. This is R. Let's say this is 100. Let's say this is 99. Let's say this is 98. Okay, sorry. Let's say this is 9. Let's say this is 81. Okay. Let's say this is 80. Let's say this is 82. Let's say this is 75. Let's say this is 98. Okay. And let's say this is 101. You want to count all the valid subarrays from L to R such that R is the largest element. R is the largest element. So guys, can you tell me what is the number which is creating R5 in this case? React with emojis if you guys will be able to tell me which number is creating R5 immediately as I open the Google chat. Will you be able to do it at 12 a.m. and prove how intelligent a Kumar K student can be IQ wise in the pro cohort? Okay, so please write that lovely answer in the Google chat. 101 is the blocker. 101 is the place where we have to stop counting. So we will only consider this range, this range. That's it. Any range bigger than this can never be valid because 100 will not be the largest number in that subarray. Clear? Okay. So this is R5. This is R5. You are enjoying it. I am also enjoying it, no doubt. So now what do we do? A simple brute force I will do. 109. 109. Yes, 100 is largest. This is second largest. I will call it valid. Even though it is not valid, I will still call it valid. I will just not count it in the answer. It is valid, but we are not counting because its length is 2 na. The question is saying that only count length 3 subarrays. But let's call it valid because it is following the rules na. 100 largest, 9 second largest, and in middle there are no elements. So you will compare with whom, right? This is valid. Now guys, you only imagine 9, 100. This is the largest element and this is the second largest element. This is the largest element, this is the second largest element. Now think intuitively. If you add a third number here, what can be the third number such that this subarray of size 3 also becomes valid? What that third number needs to be? if 9 comma 100 is valid, it means 100 is the largest number which is fixed. 9 is the second largest number. अब अगर तुमको 9 के आगे और एक नंबर डालना है सच दैट ये 3 नंबर का भी सब एरे वैलिड हो जाए, तो वो नंबर की प्रॉपर्टी क्या होनी चाहिए? मेरा कहने का मतलब क्या है कि 9,100 तो वैलिड है, 9,100 is valid. What number I can add at the third place such that this sub array also becomes valid? This number needs to be the second largest number in question mark 9 and 100. What type of number can I add? Let's see what the people write. What type of number can I add at the question mark so that the three side sub array also becomes valid? Any number greater than 9. Common sense. But I did not expect so many people to give correct answer at 12 AM. Great job, great. Let's take screenshot of this. I will remember that Kumar ke students were answering even at 12 AM for such a difficult problem. So, great job. Screenshot saved. Yeah, now it will go in the history. Okay, your kids will watch this session and they'll know their parents were answering, and your relatives also. So, any number greater than 9. So, basically, guys, if this is index r minus 1, you will just call what? You will call PGE of r minus 1. You just want to know which is the previous greater element of 9. समझे बात को? If you are able to find the previous greater element of 9, it means that sub array is also valid. So what is the previous greater element of 9? Everyone write in the Google chat. Which is the previous greater element of 9? कोई बता सकता है? जल्दी दिमाग लगाइए. Which is the previous greater element of 9? 81, 80 नहीं आदित्य था. किसने 80 लिखा जरा देखने दो. आयान दत्ता जी देख लिया. पता चला क्यों 40-50 लाख का जॉब नहीं मिल रहा है. बस यही बात है. 9 के पीछे 81 दिया है तो भी 80 लिख रहा है. थोड़ा फोकस बढ़ाइए. Now, previous greater element of 9 is what? 81. Previous greater element of 9 is what? 81. So guys, you will call PG of R1 on O of one time. It is 81. So you come at 81 and you just declare blindly that this is also valid. You declare blindly that this is also valid. You declare blindly that 81, 9, 100 is valid. Why? क्योंकि तुमको कुमार के सर taught you that any number greater than 9, if you add here, it will be the second largest. So guys, now 81, 9 and 100. This is the largest element and this is the second largest element. अब मुझे बताइए, if you want to add few more elements here, what kind of element should you add so that this part also becomes valid? Write the answer in the Google chat. 81, 9, 100 is valid. Now, what should I add in that last part so that that also becomes valid? This needs to be now the second largest number. Currently, the second largest number is 81. Any number greater than 81. Aditya Shandile, you should not write less than 100. You should not write less than 100. Because that is already confirmed. We have made the R5 blocker. We are never going ahead than that. So that we don't have to deal with two conditions. You only need a number greater than 81. So guys, 81 is at index R minus 2. Guys, can you tell me to get a number greater than 81 on the left hand side, what function you are going to call? PGE of R minus 2 एक झटके में बता देगा कि लेफ्ट में 81 से बड़ा नंबर कौन सा आ रहा है immediately. Which is the number on the left? Which is greater than 81 on the left? You can see right in the Google chat. Which is that guy? Who is that guy? So guys, PGE of R minus 2 will directly make you jump from 81 to 82. Now you can say that the array from 82 to 100 is valid. I am damn sure no one has explained you in this way. तुम कुछ नहीं कर रहे हो, तुम बस जंप मार रहे हो लेफ्ट में. 81, PGE of 81 is 82. It means 82 to 100 is also valid. क्यों? क्योंकि 81 से अगर बड़ा नंबर पीछे ऐड हो रहा है, मतलब गारंटी है एक चीज की. गारंटी ये है कि वो भी वैलिड सब एरे होगा, क्योंकि वो सेकंड लार्जेस्ट हो गया अभी. समझे बात को? समझे? क्लियर? You can see that 80 to 100 is not valid. Why? Because 80 is not second largest. You saw the point? Right? Great, great, brilliant, brilliant, awesome. If you have now understood what's going to happen, you are noticing the pattern, right? अब तुमको समझ आ गया होगा. अब नेक्स्ट क्वेश्चन में क्या पूछने वाला हूं. 82, 81 और क्या था नंबर? 9, 100. You know that this is the largest, this is the second largest. So guys, what do you think? What number needs to be here? so that this part also becomes valid. Use your brain and tell me the answer in the Google chat. What number needs to be there? So guys, how will you know the number greater than 82? What will you call? You will call PGE of 82 or its index, right? PGE of 82, right? 82 नहीं, इसका कुछ इंडेक्स होगा, समझो I5, तो PGE of I5, ठीक है? So guys, if you call PGE of, कहाँ गया? Guys, if you call PGE of 82, what will get printed? You will directly jump to 95. Sorry, you will directly jump to 98. And guys, do you agree if 98 to 100 is valid? Yes, hell yes it is. तो कुछ नहीं करना है, that's the solution. You just keep on jumping on the left and the problem is solved. So you just do PGE of R. Okay, you know that L to R is valid. Right now, you check R minus 1 and R minus 2 and see which is the second largest for those subarrays, and you keep on doing PGE of I until you hit or reach R5, and those jumpings are all valid subarrays. That's it. That's it, guys. That's it. Obviously, we are not going to cross the blocker, right? We are not going to cross the blocker. Guys, write great, brilliant, clear if these things are clear to you. Please quickly write it. Obviously, when you come at 98, you will do PGE of 98 and you will reach 101. Arey, ruk jao. As soon as your PGE crosses R5, you need to stop. Why? मैंने पता है ना R5 का limit लगा के रखा था. Because after that or from that, 100 is no more the largest element of that subarray. Clear? Okay. Thank you. Now, if you try to analyze the time complexity, it is still not that efficient, but it passes all the test cases in Leetcode. See, what are you doing? You are at R. You analyze R minus 1, R minus 2 to see who is the second largest and the largest, right? Then you just keep on jumping, right? Jump one time. Because all the numbers are distinct, your jumps can be very less, right? But in the worst case, let's say you are making 100 to 200 jumps per index R on the left hand side, okay? In the worst case, let's say it can be 1000 jumps also. So it can lead to TLE depending on the number of jumps. The time complexity in this case will be O of n into the average number of jumps you are making towards the left hand side. And guys, the same logic you will apply for the type 2 subarrays, but the jumps will be on the right hand side and you will be using the next greater element concept. Even if I take back the previous statements in type 2, you are going to use the next greater element concept because L is largest and A of R is the second largest, and the same repeat the same concept. Okay. So the time complexity is n into jumps. Why? For each index R, तुमको नहीं पता ना तुम कितनी बार पीछे जंप मारने वाले हो सकता है छोटी जंप हो बड़ी जंप हो. Everyone write in the Google chat n into jumps. O of n into jumps. What is the time complexity? At each index R, you just keep on jumping, but हमको नहीं पता कितना jump मारना पड़ेगा. Write the time complexity. N into jumps. Only Aditya Chandila is written. Okay. But guys, if you do not understand this concept, now this problem is not going to work out for you. Okay. Somehow you need to understand this concept. Okay. So that's it. N into jumps and life is going great. Now we just need to do the optimization. Basically, we need to find this total number of jumps in like O of one time. We cannot waste much time in trying to find the number of jumps and all those things. You just need a way to find it out very quickly, and this is also very simple. But this was not to be done in the Leetcode contest. Leetcode allowed you to, just do n into jump solution and pass it. Okay. So it's efficient solution we'll discuss in the next video. Okay. Ram. Well, let's go stop. Yeah.
So, guys, welcome to the session. Today, we will be going to discuss problems from the Leetcode weekly 466 contest. Okay, so let's begin with the discussion. Okay, so, guys, yeah, as usual, first of all, we will discuss the beginning problems, then we will move to the advanced problems. Okay, and before that, guys, before that, I would like to show you one document, and you guys are, I think, aware why I am showing, because today's lead code B problem was directly from our course. Are you aware? Similar problem exists in our course. Yeah, great, awesome, Akashish. So, guys, every time we recommend you, we always say this, that this is a prerequisite document, right? This is not the main course document. This is the sub set of that, right? It is just 1 or 2% from the actual 850 900 hour course, right? But if you even complete this one, because why? Because this consists of very important problems from each of the topic, right? So if you do this fully, you will be at least aware of all the topics, at least from the basic level, right? At least from the top, you will have the overview of every topic, right? And you would be aware that how to tackle problems in OA and CP, right? So let me send that in the chat as well. I believe everyone is already having this, right? And every time I recommend that before going to the contest, at least solve this prerequisite document, right? Today's B problem was directly from our course, if you are aware, right? From a hashing problem. So let's begin with the discussion now. I think everyone is now aware that you have to complete the prerequisite course. And why? Because it's very, very important. It contains most important problems from each of the topics, right? Okay, are you okay with this? Is it clear? Everyone, can we begin with the discussion? Right, yes or no? Great. Awesome, guys. Awesome. Mind blowing. Let's begin with the first problem. Right. Great. So the problem says you are given an integer array nums of length n. In one operation, choose any subarray nums L to R, where L can be R can be between 0 to n, and L will be less than equal to R. Okay, and replace each element in that subarray with the bitwise AND of all the elements. And you have to do what? Return the minimum number of operations required to make all the elements of nums equal. Okay. And subarray is obviously a contiguous non-empty sequence of elements within the array. I believe this is already something which everyone knows, right? Okay, great. So let's begin with the discussion. Any one of you aware what is the problem asking to us? I have read the problem in front of you. Any one of you understood what is the problem asking to us? What do we have to do? What is given to us? Any one of you having any idea? Any one of you having any idea? Or should I start explaining what is the problem asking? What do you think? What should we do? Oh, zero for same elements, one for more than one. Okay. But what is the problem asking? My question was that. What do we have to do in this problem? What is the task? Can anyone explain? No, I'm not asking of solutions, guys. I'm asking for the problem statement. If you are having the solution, you must be knowing what is the problem asking, right? So you can write that. I want to see how many. See, going to the solution is only a 50% part, because you will get to solution only when you understand the problem fully. You are aware what is the problem asking, what is given in the problem, then only you can reach to the solution, right? And that makes your that gives you AC, right? So for getting AC, you need to do two things. First part, to understand problem correctly, and second part is obviously the solution. So yeah, replace and from range and make all elements. Yeah, Rohit, correct. Nice, Sahil. Great. Sahil gave the first correct answer. Nice, Pragati, Nitika, Shamira, Komal, Alkashish, Priyam. Awesome, guys. Brilliant. Brilliant. So guys, let's go one by one, and let's divide this big problem into a sub problem. Although it's only a small problem, but still we can divide it into sub problems and chunks. Okay, so let's do that. Basically, we are having what? We are having a nums array. We are having array nums. Okay, this will look like this. It will have some elements. It will be of size n. Size is n. Okay, now what do we have to do? In one operation we have to choose a sub array. Let's say L is this, R is this. Okay, so I can choose subarray from index number L till index number R, and I know everyone is aware what is a subarray. Correct me if I'm not, wrong, right? Do you guys know what is a subarray? Any one of you knows what is a subarray? Right, guys? What is that? Explain. Although I know everyone would be knowing this, but still, I want to see at least one of you writing what is a subarray. Yeah, great, awesome. Contiguous elements from L to R. Great, awesome. Yeah, you are correct, guys. That is what the definition of a subarray. Great. So basically, in this problem as well, what do we have to do? We have to choose a subarray. Let's say I choose this subarray. So it will have, let's say, elements of A, B, C, D, E. So what I can do, I can replace each element in that subarray with bitwise AND of all the elements. What does it mean? Bitwise AND of all the elements, right? That means I will take bitwise AND of B and bitwise AND of C, then D, then E. I will take bitwise AND of all of them, and what do I get? I will get some value, let's say K. Now what do I do? I will replace each element in that subarray with that value K. That means this B will be replaced by K, this C will be replaced by K, this also K, this also K. In one operation I can do this. Okay, and now it's up to me. I can even choose this L and this R. That means complete array can also be chosen. There is no constraint. Then in that case, this will also be replaced by K, and here I will take AND with A as well, right? Is this much clear? What is the problem saying? Is this much clear to everyone? Right? Yes or no? Awesome, brilliant. So guys, if this much is clear, now what do we have to do? We have to return the minimum number of operations required to make all of the elements equal. That means we have to make all of the elements equal. So what do you think? What should we do? Our greedy mind will say, since you can observe one thing that if I am choosing a range of L to R, finally I will replace all of these elements with what? With what? With a final value K, right? This K, this K, this K. That means all of them are becoming equal. That is what we want to achieve. Minimum number of operations required to make all the elements equal. So, do you get some observation from this that my greedy mind will say, if I have to minimize number of operation. So what is the minimum operation I can do? One operation. What is that operation? I will choose this whole array consisting of A, B, C, D, E. I will generate a bitwise AND, and I will replace all of the elements with that value. This also, this also, this also, this also, this also. In that way, I will have in one operation making all of the elements equal. Is this greedy strategy e- good or not? What do you think? What do you think, guys? Is this greedy strategy good or not? What are your views, ideas on this? What do you think? Is this good? Okay, great. But there is a case, guys, when we can even get something lesser than one. We want to minimize operations. Is there any way when we can do this even with zero operations? What do you think? When all of the elements are equal, what do you think? Do we still want to find the bitwise and let's say all of them are A? Then do you think we will find the bitwise and replace that with K? Do you think? No, guys, because our final goal is not to find the bitwise and our final goal, this is just a, let's say, factory function. It will just give us a final result based upon the input parameters, and we will use that result. It is useless for us. Even if there was or any other operator here, it was useless. We are concerned with the final value, and we are replacing all of the elements with that final value, right? We just want to make all of them equal. That is our main target. So if they are already equal, do you think we need to do this again? Do you think that is required? What are your views? Great. That means what will be the number of operations in that case if all the elements are already equal? What do you think? Yeah, great. So basically, I believe that everyone is now aware of the actual approach. What would be our final approach? Let's construct that final approach. What is that final approach? Two parts. If all elements are already equal, we will return zero number of operations. Why? Because already equal. That is what we want to achieve. Otherwise, choose if all of them are not equal, all not equal. What do? We will choose L is equal to 0, R is equal to n minus 1, that is complete array as a subarray. Replace all of them with k, right? And in that case, we have one operation, right? So these two cases we have. Is the approach clear? Yeah, great. Awesome, guys. Is the approach clear? Everyone tell me. Is the understanding of approach clear? Can we discuss the code? Awesome. Great. Let's discuss the code as well, guys. From the doc, we have the code link as well here. Let me open the code link. Okay. Where is the code? It's here. Okay, great. So what are we doing, guys? What are we doing? We have just initialized the flag with true. What does it do? It will tell us that if all elements are equal or not. As soon as we get any element which is not equal to nums of 0, that means any element which is not equal to the nums of 0, what does it mean? We have at least two unequal elements, right? This is what it does. Is it clear? I will compare every element with the first element of the array, and if any element is not equal, then I can say that yeah, at least we have two different elements in the array. That means all the elements are not equal. Can we conclude this from this thing? Can we conclude this? Tell me yes or no. If any two elements are not equal, we can conclude that at least we have two different elements. So array is not a single element array, right? All of the elements are not equal, right? So in that case, what do we do if any two elements are unequal? This case, right? What are we doing in this case? Second case. This is the first case. This is second case. What do you think? What should we do? Any brilliant student? Tell me. Yeah, return one. Awesome. Awesome. That is what we are doing. We will just update this flag and break. And if this flag is now false, what do? We will return one. Otherwise, if it is true, that means we are aware that all of the elements are equal. So we will return zero. That means already equal. So no need to do anything, right? Yes or no? Is the first problem clear with everyone? Can we move on to the next one? Right? Yes or no, everyone? Nice, Komal. Great, Sahil. Everyone right? Yes or no? Okay, great, Nitika, Lakshit, Prem. Awesome. Let's begin with the next problem. So this is the next problem, guys. Let me share the problem link as well with you guys in the chat section, or even I can show in the screen. Okay. Yeah. So guys, what are we doing in this problem? I will show you. First of all, you need to read the problem. I am pretty sure that at least some of you have not read the problem, right? Not aware of what is the problem statement. So giving you guys 10-20 seconds to read the problem. Everyone focus on my screen and read the problem. And once read, let me know in the comment section so that we can begin with the discussion. Everyone read the problem statement. Okay. Everyone read the problem statement, guys, fast. Okay, I think everyone is now ready. Can we begin with the discussion? Can we begin, guys? Great, Subhash. Or do you want some more time? Okay, great, awesome. So, what is the problem asking? My first question, everyone is already aware and writing. Great, awesome. Problem is saying to convert all characters to a string, returning minimum operations for doing. So, okay, Komal, correct. Minimum number of operation to transform S to set of characters A. Okay. Pragati, great. Nice, Subhash. Minimum operation to convert int all elements to A. Okay, great. Awesome. So, guys, yeah, you guys are correct. Let me begin with the discussion. What is the problem saying? Okay. So, basically, guys, now focus here. You are given a string S consisting of lowercase English letters. Okay. That means we are given a string like, let's say, string is B, D, C, A. Okay. Now you can choose any character C in the string. Replace every occurrence of C with the next lowercase letter in English alphabet. What does it mean? I can choose, let's say, any lowercase character. Let's say I choose this D. I can replace this D with the next lowercase letter in English alphabet. That means in A, B, C, D, E, F, G. First of all, let me check everyone is aware of A, B, C, D, E or not. First of all, tell me, guys. This is a prerequisite for this problem. Are you guys aware of ABCDE, or you want me to give a tutorial or a crash course or some sort of documentation for that? Great. Everyone who is aware of ABCDE can write yes, so that I can know my audience is aware of ABCDE or not. Or if anyone is not aware of ABCDE, you can write your names. Okay, great, awesome, guys. You are aware. Very nice to see. I'm very very happy to see my audience is very young and grown up. Oh, great, great, awesome, guys. So yeah, let's come back. At least I'm now pretty sure that everyone is aware of ABCDE. Okay. So guys, yeah, if you are aware, can you tell me what is the next letter in English alphabets after D, with which I will replace this D? Yeah, great. That means I can replace this D with this E. Okay. So the string will become BECA. And my final goal is what? Do you know? My final goal is to make all of them equal to A. That means my final aim is to get this string S dash. That means this is correct position. Now we want to make this also equal to A. How can we make? We can make this C to next letter D, then E, then Z. Then after Z, what does it come? It's reverse circular, right? A, B, C, D, X, Y, Z. After Z again A. Okay. Remember this. That means how many operations? What do you think? First of all, number of operations to reach Z, let's say it is X, plus 1 because we will convert that Z into A. Next, then only we can achieve this A. Is this much clear? There is operation replace with next character for every character if it is not A. So all are achieved one type of operation, that is if all char B is convert. B minus require 25 operation. Why they asking minimum operations? What is the case that require max operation? Yeah, okay, great question. So see, Kurmalingam, see, the max number of operations can be, I will show you how. See, you are saying what you are saying. Let's say, very good question. I appreciate everyone that you guys have at least asked a question. Great. So see, focus. A, B, C, D, E, W, X, Y, Z. Right. Then what? Then again A. Right. Let's say you are standing here. So one you want to reach to this A. You will do what? W to X, X to Y, Y to Z. Three operations here and one operation here, right? This is the minimum operation case which you are saying. This much is clear or not? Is this much clear till here? Yes or no? Great. That means four operations, right? Now how can it be maximum? See, you have reached A, but somehow your memory is lost. Or I will not say to you, but for let's say person X who is doing this, okay? Let's say he's a dumb, he's a foolish person. He reaches this A, but still he wants to go again a cycle again, A to B, B to C, C to D, like this 26 times again. 26 plus 4 equal to 30. In 30 operations also you can reach this A. Again plus 26 in 56 operation also you can reach this A. You can go loop, loop, loop. That will be the max case. Okay. Although we guys are intelligent, but there could be a person X who is dumb. For that type of person, the problem is saying minimum operations. Okay. Yeah, yeah, great. So is this much clear? Everyone tell me now. Is this clear, everyone? Great, awesome. Now let's come back to the original problem. So guys, yeah, this is what we want to do for every element. We want to make it equal to A. And how we will do? We will check its position. C to D like this till Z we will do X plus 1 from Z to A, right? Now guys, how to reach to the solution? How to get the final number of operations? Let's say the original string was S is equal to same, let's say take S equal to B D C A. Okay. Now let me erase this much part. Okay. Okay, now we have enough space. So guys, so guys, what has happened to it? Yeah, sorry. So guys, yeah, first option is that this is in correct position. Now we convert this B to next character C. So string will look like C D C A. Then we convert this C to this D. Then it will be D D C A. Then this C to this D D D D A. Then this D to E D D A. Like this we will do every character we will reach to A, right? So in general, what do you think, what will be the minimum operations which you can achieve? Very simple guys, we have done the same thing here, right? We will just check what position, right, in this form A B C D E. Let's say you are standing here, you will calculate number of operations to reach Z plus 1 for reaching from Z to A, right? This is what we will do, right? This is our approach. Yes or no? But the problem is that this is done for one character, right? How will you calculate for whole string? How will you make sure that minimum operations required for all characters is best? How will you calculate for whole string? What do you think? Because in the problem you can see, return the minimum number of operations required to convert S into a string consisting of A. Okay, is this clear? What do you think? How can we do? How will we do, guys? Anyone? Okay, Rohit, great. Basically guys, for every character what can we do, we can check the steps, right? Yeah, yeah, great, awesome, brilliant. And how can we do it mathematically? Anyone aware? This is a theoretical, right? We are doing the dry run. In the program, what you will write in the code, I will explain you. See, we will write the formula like this. Let's say we are calculating the steps, so steps will be equal to what? 26 minus C minus A. Okay, and mod 26, or let's say forget about this mod for now, let's keep it short. And now guys, you will ask me how will it work? Yes or no? Why is it working? Let's say my character is D. I want to check how many operations required to convert into A. So I will put this character D here, right? So I will get some value, like for A we are having 0, we want to get the index, right? So B is 1 for all the 26 characters. For D we have 3. So this is what we will get, right? We will put this D here. So D minus A will be what? ASCII value of D is, let's say, y. this is x, so we will get here 3, right? And that is the index of this d. Is this much clear? We will get the index of this d, right? We will get the order in a b c d e. What is the order where it should be present, right? We will get the position of this d. Yes or no? Because code is not very smart, he is not knowing abcd, right? In the beginning also I asked you guys are aware of abcd or not. So you guys are intelligent, but code is not intelligent, right? He wants to get the index. Yes or no? Is this much clear? That we will first of all get the index. Right, now what will we do with the index? Let's say you know a b c d e x y z. Let's say you're standing here, you get 3, you are aware that your position is this. You want to go here, how will you go? All of them are 26. 26 minus position of 3, it will be 23. So this is the 23 steps you will take to reach here, and you can even check that from D to Z it will be 22 steps plus one step from Z to A, right? So this formula is helping you to get the total steps to reach A, right? By going in clockwise direction, in this direction, right? You cannot go anti-clockwise. In the problem only it is saying you can go from character D to the next character E, then F, like this. You cannot go to previous character, right? Is this much clear? Is this formula clear with everyone? Okay, great. Anyone having any doubt, you can ask. Okay, feel free to ask. Now, guys, do you think this formula is always correct? Do you think will it work for every case? 26 minus C minus A. Do you think it will work for every case? Or is there any case when it will not work and we need to modify it? Okay, I will show you one case. Everyone, please focus. Okay, everyone, please focus. I will be going to show you one case. So, guys, when you are already at A, what will you do? A is at zero index, right? We have seen. And you want to achieve also A, and you are already A. So you will put here A in place of C, right? So A minus A will be what? Zero. A sky value of A is, let's say, X. Here also it's X. So you will get zero. That means you are already in the zero position. But when you do 26 minus zero, you will get 26. Boom. You are already in the correct position A. Still you want to go a whole cycle and reach to this A. 26 steps. Like I said earlier also, a dumb person will do this, right? If you are already at A, why will you do that? For that reason, for this condition, what you will do? You will take mod here for this whole steps. Mod 26. So when you do mod 26 of 26, you will get 0, and that will be the correct answer. And in the rest of the cases, let's say you are getting any value less than 26, let's say 24, mod is still 24 only. So yeah, it will work for other cases as well. Let's say it is 2, so 2 mod 26 is still 2. But as soon as you get 26 for the A case, you will get it 0, which is what we want, right? So is the formula, final formula, clear with everyone? 26 minus C minus A and mod 26, this formula. Let me show you with the different color, this formula. Is this formula clear with everyone? Can we discuss the code? Everyone write yes or no? Is the formula clear with everyone? I want yes or no from all the 23 people present here. Great, Kumar, Sahil, Pragati. Awesome, mind blowing. Let's discuss the code, guys. Code will be very, very simple as we have discussed the approach, right? So, yeah, first of all, we are using this formula distance, right? And we are calculating the max of this. Why do you know? Anyone aware? Why we are checking this distance for every character and taking the max? Anyone aware of this thing? We have discussed that we will check the distance, right? Or steps, whatever we want to name. But why we are taking the max of all steps for each character? Why? Why? Anyone can tell? People who were writing the solutions earlier, now tell me. Anyone want to take a try? Or should I explain? Brainstorm your mind, guys. Minimum character to reach is the final. Yeah, correct. Because, guys, let's say string is A, C, D, C, B. Okay. Let's say this requires 0 steps to reach A. Why? Because it's already at A. Let's say it requires 23. It requires, let's say, 22. Let's say it requires 21. Whatever. These are random values. Okay. Don't think that this is the actual value. These are the random values. Just focus on the expression. So guys, let's say these are the steps required for each character. So will I be dumb person X and say that yeah, I can achieve A in 0 steps considering this index? No. Why? Because we want to take the maximum of all of them and return that. Why? Because we want to make all of the characters equal to A, not only one character which is taking the less steps. We want the character which is taking the most steps, because we are sure as soon as this character becomes equal to A, all the characters which require the lesser number of steps than this 21, 22, 0 will be taking even lesser time. Let's say this requires 10 seconds. Okay, 10 seconds. These people will require 8 seconds. This will require 5 seconds. This will require 0 second. Okay, that is why we are taking the max. Is this clear? Intuition clear? Everyone tell me. Everyone write yes or no. Awesome guys, brilliant, mind blowing. Awesome guys, great, great. So yeah, that's what we are doing. Okay, that is why we are taking the max and finally returning the answer, right? So let me give you guys the link of the doc as well, so that you guys can refer to all the codes and problem links for your reference. Let me share in the chat as well. Okay, everyone can open the doc and see the codes whenever you want. Okay. I think the access is not there for everyone. Let me give the access as well. Viewer access. Okay, great. Let me send the doc link once again. Okay. So guys,